we need to compute dy over dx, where y is arcsin square root of x. So the inverse trig derivative. So here we have a few of them. So let's recall on arcsin. Let's call it arcsin u. In this case, u equal to x. We use chain rule. Arcsin are cosine, arc tangent, arc cotangent, arcsecant, arc cosecant. Now, here's how we will remember that. These are, let's look at the left hand side first. This derivative dy over the x upon of this will gives us, let's say, prime. Let me write this one, prime u, is just a function in x. So we use chain rule. So remember that this one only gives us a fraction. So just now let's look at the left hand side first. Fraction. So for sine and secant, so you see s here, that will be subtraction and square root. Memorize that as you think of as subtraction and square root. Subtraction, so you have square root, you have subtraction. You have square root, you have subtraction. Now, because this is chain rules, u prime everywhere. And now this would be 1 minus u square. This one is a bit different. U square minus 1 u. For tangent, you think that's s plus 1 plus u square. That is for the left. For the right, you just put the minus sign and it's all good. So for the right, I just copy the left with the minus sign. Minus. So let's come back to this question. You need to compute dy over dx, arcsin square root of x. Yeah, so in some book they will write sine inverse square root of x. So this is arcsin. It's not 1 over sine x, no, that's different. This is the inverse sine of x. Arcsin u prime divided by square root 1 minus u square. In our case, u is square root of x, arcsin square root of x prime, square root of x prime, square root 1 minus u square, square root of x square, x. Up there you have x power 1/2 prime. Down there you have 1 minus x, square root of that. 1/2 times x minus 1/2 over square root 1 minus x. 1 over x square root x 2. So this is 1 divided by square root of 2 square root of x times square root 1 minus x.